So as mentioned, I'm both in the computer science and literary community, and one of my first experiences reading my poems to a poet was to the Poet Laureate of the United States, and he told me, "That's amazing, the words on the page are beautiful, and you read them so badly you make them sound ugly. So therefore, I mostly read my talk because I want to prove him wrong eventually." So if you'll excuse me while I do that. A few years ago, I started writing a natural language generation program for a DARPA project. Early on, the program didn't do much, and it wasn't required to do much. But as I went on, the program drew me in, and I tried to make it think like a writer. In late December of last year, I decided to hack together a quick test to see whether it could write poetry. Overnight, that program, called Inkwell, wrote 2,000 poems. Pawing through them, I found this one. It's an English language haiku. Deep in the dark, the power of snow, walking in the deepness. So I mentioned I'm a working poet, and this is a good English language haiku. I'm going to read some other examples to sort of give you an idea of what the program can do. And then I'm going to kind of explain how the program works more or less. A revision of a Robert Frost poem. It's the last two stanzas. He gives his harness bells a cloud to ask if there is some spot. The only other music is the illusion of worn wind and cold mound. The logs are good, glad, and tight, but I have words to keep, and miles to go before I sleep, and miles to go before I sleep. So I'm going to pause and tell you what you're going to see in the talk before I continue with some of the poetry. So one of the things you'll see that most everything you know about software engineering doesn't apply to this program that I'm talking about. There are no requirements aside from things like write English real good, think like a poet. It's a research instrument that's helping me explore what thinking like a writer means, and it's not a product. I have no customers. I have no product owners. I have no deadlines, no deliverables. There's only one person on the project, yet IBM Research pays me a ton of money to work on this, which you might find interesting. So I'm going to show you what ingredients make up a modern AI program. I'm going to show how soft components can be combined using optimization to produce some interesting language. There's a conclusion that you can draw from this, which is machine learning alone won't produce full AI. And I had the experience of taking these poems that I'm going to show you to a writer's conference where I think it passed a version of the Turing test. More haiku in the manner of Walt Whitman. Awake in the dark, the edge of the water can spread in your presence, like Adam Smith. Scrupulous in the twilight, the price of gold chases the way of the world in power. Like the King James Bible, time of life issue, a bird of prey pulls up out of the way into the palm. In the manner of Walt Whitman, he gives his harness bells a whip to ask if there is some end. The only other show is the push of a couple of winds and a falling chip. The woods are clean, murky, and vigorous, but I have roots to preserve and miles to go before I sleep, and miles to go before I sleep. A crooked rag day, by myself, dunking distracted sardines. Day after day in the man's can, a man can. Something funny about the program. Tuned adrenaline, my music, a beat boogied head full. So part of the goal of the program is to imitate other writers. So this is in the manner of Bob Harper, a theoretical computer scientist. Whose sums these are I express I know, his unit is in the body though. He will not see me entering existing to consider his sums operate up with snow. My smaller horse must evaluate it interesting to keep in without a family discriminating. between the sums and polar form, the darkest mean solar day of the fundamental quantity. He gives his influence devices an exit to pass along if there is some statement. The only other element is the use of benign context and yielding element. The sums are logical, insensitive, and severe, but I have expressions to position and large indefinite amounts before I sleep in, and large indefinite amounts to go before I position. A few more haiku. Not this fatalist murderousness death watch, but your dead subroutine. A bitch, this deep in trick, a fortiori not a man. Functional function, the orchid, even when it's lisped functionally. So some of you are thinking that Inkwell haiku are simply crazy, created by a random process. However, real contemporary haiku are crazy too. So Inkwell is normal, sort of. Others might be thinking that Inkwell is a great poet because it can just rattle off one decent poem after another. But I've selected the ones you've seen, just as real poets select the ones they try to publish, and editors further select from those. Here are some of Inkwell's duds. That was the duds right there. And very good poets deliver duds. So here are a pair of couplets by T.S. Eliot and a line and a couplet by Dylan Thomas. So today, this insect and the world I breathe. I am aware of the damp souls of housemaids sprouting despondently at area gates. So my research question is this: is it possible to write a program that can work with language the way an accomplished poet can? I suppose this is the same as asking whether a program can think like a poet. What do I mean by thinking by a poet? For many, writing is information transfer. There are propositions you want to get across, and writing is how you do it. Short, simple, direct, declarative is the way to go, maybe. This is a decently well-written bit of information transfer. The summer homes on Long Island were closed. Tonight I watched a ferry begin its crossing to Connecticut. The moon was rising, and as it rose, I thought about how the houses are not part of the natural world, and what the island looked like to early Dutch sailors coming upon it, like something new. This, however, is how F. Scott Fitzgerald wrote it on the last page of The Great Gatsby. Most of the big shore places were closed now, and there were hardly any lights except the shadowy moving glow of a ferry boat across the sound. And as the moon rose higher, the inessential houses began to melt away until gradually I became aware of the old island here that flowered once for Dutch sailors' eyes, a fresh green breast of the New World. So there's something more going on in this version, but what is it? Images, mood, a vivid, continuous dream, as John Gardner would put it. The first gives us the bits, this one gives us a story. Part of it is that writers think about words, what they do, and how they work together. The research goals of the original research project were more modest, to assist human creativity and to mimic specific people. This to construct anti-malicious persuasion campaigns. So the basic idea of that research was some other group would find someone who was doing a malicious persuasion campaign, would map out their social network, would figure out the personality types of all of the people involved, figure out who might be persuaded to drop the malicious campaign. Then my program would imitate the person that these people would listen to and try to talk them out of it. So that was the sort of simple goal that I had. And that's the program I turned into the poetry writing program. Here's the observation I started with. Consider a passage the way a writer does. It's a series of words which can be revised. Words and phrases can be changed to obtain effects like exhibiting personality traits, word music, terseness, etc. If you pile them up as alternatives to parts of the passage like this, and if you can measure the improvement or degradation numerically, then you can use Simulated annealing, to do an effective search of the space of revisions for something good, that is to say, something that imitates the person, something that demonstrates certain personality traits, whatever it might be. So I know you guys like code, so I've written this in Common Lisp, which is a language I'm relatively familiar with, and this is the heart of the program. This is the framework for simulated annealing, and the yellow stuff, which you might be able to see, is where you plug in functions that do the analysis of the revisions. To assist creativity, Inkwell can be directed to be conservative, that is, write like other writers and choose words close in meaning to the trigger words, or be wild by going against the grain by choosing distant words and using uncommon wordings. Inkwell can satisfy word and phrase-oriented constraints, such as word length, rhymes, echoes. An echo is sonic similarity, and meaning senses. Constraint satisfaction is soft, meaning Inkwell considers the weights of each constraint, numerical weights, and tries to find a good balance. Inkwell can bias wordings to exhibit specified big five personality traits, and they are openness, conscientiousness, extroversion, agreeableness, and neuroticism. This is the primary personality model that all of the sentiment analysis and other sorts of applications are using these days, in order to favor certain types of words and to match as best it can a specified writer's language use model, which includes n-grams, which is a series of words that have occurred in that person's writing, disfavored words, language, music, word length, and any computable statement. So to give you a little show, if you asked Inkwell to find synonyms for the word dog in the semantic category animal, and find words that begin with D, this is some of the words it would find. So those are all dogs whose names begin with D. It didn't do the plural. Inkwell can invert any or all of the constraints so that it's not only possible to sound like a specified writer, but instead to sound like anyone but that writer. So here's how it works. Inkwell takes a template that specifies the text to be generated or revised, along with a set of constraints, and compiles that into an optimization function that computes a misfit score for a proposed wording. So in other words, it will examine the space of revisions or changes, compute how well that satisfies the constraints, and it does optimization based on that. That function is invoked by a parallel simulated annealing engine, which endeavors to find a wording that minimizes that function. The resulting text is then subject to a small set of syntactic transformations to produce the final English text. Inkwell templates are expressions in a domain-specific language for generating text. In the context of natural language generation, a template typically implies fill in the blanks, whereas Inkwell templates can be all blanks and with varying numbers of them in a single template. The revision examples I showed used templates closer to the naive notion of template, but the Haiku templates were all blanks. They're very abstract. This is an example of a revision template. This is for the Frost poem that I showed you earlier. One on the conventional end of the spectrum, but still not simple. This part is the text to be revised. Notice it's filled with fixed words. This is because I want to retain a clear resemblance to the original with only some specific wording changes. This part establishes global settings for constraints and bindings for word choices. For example, this tells Inkwell to find synonyms for the noun house and consider them as wording changes. The choice of synonym could affect the personality exhibited by the text. This one says, find synonyms for the verb think, but to consider only synonyms that are in the semantic category cognition. Bindings are used to ensure the same word is used in several places. Here a word is chosen for snow, and that same word is used everywhere a reference is made to W2. This says that whatever word W2 ends up being, it should be different from the word W1 and should rhyme with it. And here's the rest of the template. But word choice doesn't need to be based on synonyms of a given word. Inkwell uses a mechanism called a sense to find words that have particular meanings or connotations. We'll talk about senses a lot later on, so this is just to give you a little taste of it. And here's the rest of the template using senses. And then here are the words that make up referenced sentences. So a farmhouse sense is some kind of weird data structure that talks about the words farmhouse, farmhouse, and shed, but some more stuff along with it. So Inkwell is a small program with lots of data. I've used publicly available data sources, but in most cases I've expanded them algorithmically. Inkwell uses WordNet expanded to 160,000 entries, which are words and phrases, a table of the 20,000 most common words ranked by frequency, the CMU Phonetic Dictionary expanded to 220,000 words, a rhyming dictionary of 42,000 words, a STEM dictionary in the Porter Stemmer, the Google Ngrams, which were extensively processed to eliminate noise and to connect its words to WordNet, Ngrams for a set of well-known writers, and just 40,000 lines of Common Lisp code. So the Google Ngrams are sequences of 1, 2, 3, 4, and 5 words in a row that occurred in a body of 8 million books that they OCR'd in a few years back. The result is a 15 gigabyte running image once everything's initialized. The weights associated with writing craft elements are called bonuses. There are two kinds: static bonuses, which are computed when the template is compiled, and dynamic bonuses, which are computed during the optimization process. So now I'm going to start to show you some of the components that go into what's measured in order to decide which revisions or what text to generate and what sort of characteristics it should have. So let's take a quick look at how personality is computed. So as I mentioned, Inkwell uses the Big Five model, which has these dimensions. The algorithm is based on the work of Tal Yarkoni, who found correlations between text written by individuals and their personalities. Yarkoni's work is based on sentiment analysis, in particular the work of James Pennebaker and his colleagues and students. The approach is to define psychologically significant categories and then map words to those categories. So these Yarkoni coefficients, as they're called, were machine learned from pairs of essays written by undergraduate psychology students and another assessment that measured their Big Five personality. And here are the categories. So you don't have to look at them too carefully. There are things like function words, so things like pronouns, etc. But things like insight, discrepancy, inhibition, tentativeness. The big idea is to take a text, count the number of words in each of these categories, and then compute a simple linear combination of the Yarkoni coefficients and the based on the percentages of words in each of the categories. So here's a simple example. Here's a text we want to analyze for what personality it displays. The sentence is, "Reading Gabriel's essays is pure agony." So here are the category counts and associated percentages. So it's a short sentence, so there isn't much to see. And here are the resulting personality characteristics. The blank means that there is neither evidence for nor against extroversion. So that's kind of an example of how simple these computational things like personality analysis, sentiment analysis are. So when you see applications that use that, they're using something not much more complex than this. So let's look a little bit more at some of the stuff that Inkwell uses. WordNet is a lexical database for English containing syntactic data, glosses, which are dictionary definitions, and a variety of synonym types as links. It contains both words and phrases. Roughly speaking, it's the database everyone in natural language processing uses. For example, if you go to Google and say define bloop, then it pulls up the first sense of the meaning of the word that you typed in from WordNet. You can see some of this is the entry for dog. You can see some of the odd synonym types as well as some entries I added, such as gloss words, hypernym chain, and primary synonyms. These are caches for sense-related computations that Inkwell does. A hypernym is a more general class, and a hypernym chain is a sort of ontology chain. So I've tried not to load in big ontologies or other sort of hardcore psych-like AI stuff, but to rely on just the words and what they mean. The synonym types you might not recognize are roughly class, subclass, and instance. We'll see some examples of that later. And part whole. An important find was the CMU Phonetic Dictionary. Here are what the entries look like. The vowel encoding includes stress strength, so it's possible to reason about the rhythm of text. Using WordNet, I was able to expand this dictionary algorithmically. I used this dictionary for algorithmic rhyming. This is important because literary writers care a lot about how words sound. The idea is simple for how to compute rhyme, but the implementation is a little tricky because small details make a difference. And also, coming up with the algorithm is not very simple. First complication is to decide how much each of the constituents rhyme. Here are my strength assignments for vowels, and here are the consonants. So you don't have to look at the details, but the consonants tend to sound more alike than the vowels do. All these assignments were derived from my and some other poets that I know's subjective estimates. So the basic algorithm is simple. You get the phonetic spellings of the two words. You scan from back to front. Remember, so the end of the word is where the rhyme happens. Accumulate rhyme strength. Decay the strength of rhyme as you move to the left, so syllables near the front of words count for less. There are some complications. The phonemes to compare don't always line up perfectly, so offsets matter. Included in that is when one word is longer than the other. Everything so far is pretty linear, but the perception of strength of rhyme isn't, so the shape of the curve needs adjustment, obviously like this. And here's how the ingredients measure up in the example of fictional and critical. So some of how it reasons about it. And here's the final rhyme strength for critical and fictional. So poet friends have commented on the imaginative rhymes Inkwell finds, such as gulp and hole up. There's a rhyme cache used during processing because the algorithm's a little bit lengthy. Here's an excerpt. There's a similar echo cache. So these are the relative rhyminesses of boat and spot, chip and whip, draw up, pardon me, fuck up, bundle trouble, brook prick, trip, skip, stomp, slip. And I use a weird representation to make hashing fast because of how often this cache is hit. So each key is a string and basically encodes in the first character how many words, it encodes as a character how many words are in the entry. The second character is how long the first of the words are in the example of 2, and then the 2 words are concatenated together, and then it generalizes to longer words. So echoes are complicated too. To compute an echo score for 2 words, gather all their phonemes and find the relative strengths of sonic similarity. But take into account the order of similarities. That is, take into account how much the echoes approximate a rhyme. The rhyme and echo values are not comparable. Here is the echo value for fictional and critical. And here's an example excerpt from the echo cache. So these are words, pairs of words that echo. Pale and plague, sort, rot, prophetic, decrepit, deem, meet, neighboring tapering, whole hollow, skeletal select, present pristine, load up, hold up, destined diagnosed, present resident. So I have about 75 writer samples that Inkwell uses for mimicking writers and sampling for haikus. With them, it's possible to have some fun exploring strange questions like, what's the best rhyme in the King James Bible for the word programming? Here are 3 good ones: protesting, the crackling, no reckoning. And here are 5 of the better choices of the better echoes for computer programmer in a couple of texts. Provoked me to anger. That kind of sounds like computer programmer. Most persecuted by man, compound for gray amber, come from yond poor girl, program a computer. So this is from a book of essays of mine, so it's probably not that surprising. So you might think, well, this is all pretty straightforward. I've done about 3 or 4 different types of approaches of how to do algorithmic rhyming in echoes. Because for each of the ones that I tried, sometimes the things sounded about right, sometimes it didn't, and so I had to try various things. That's why it's kind of not like regular programming in a certain way, because I didn't know what algorithm was going to work, so I had to discover what they were. Next thing is an n-gram. So, for example, a 3-gram is a sequence of 3 words that have appeared in a text. The numbers to the right represent the frequency of appearance in the 3-gram in text. So this is primarily used for Inkwell to produce grammatical sentences. The representation is tricky, and I won't explain it. But this is, again, the strange representation is so that hashing is really fast, because you'll see how much these caches are hit. So counting n-grams is easy, but scoring is harder because the n-grams have associated frequencies, and the lengths of passages being compared are not always the same. The final thing, and the only place that Inkwell knows about English, is it works with canonical forms of words and phrases. At the end, it must compute the required forms. We'll see what that means. This is complicated because English is not regular and phrases mess things up. So here's some of the entries from a cache. So one of the phrases in WordNet is hard to please. And so at the end of the computation, if we say, well, hard to please is used as an adjective and we need the comparative of it, then it returns harder to please. And so the superlative is hardest to please, etc. So I mentioned that from these templates, we construct a misfit function. This is a typical misfit function. It's a function in Common Lisp. It's stereotyped but lengthy, with many expensive function calls in it. This is called in the inner loop of the simulated annealing optimization process. So let's take a more detailed look at the flow of control and data through Inkwell. First, some other component that wants to say something constructs a template, perhaps in a domain-specific language, like the one that the Haiku module uses, or a general template. That domain-specific template is parsed and compiled into a set of specs for halos, which I'll explain, constraints, and predicates, as well as word and phrase selections specs. The word selection specs engage with a complex search of WordNet using either expanding synonym searches or sense-based searches. This is a parallel operation. This produces a set of optimization data structures and an optimization function, which is a Lisp function that is compiled. And this is the function that is minimized by simulated annealing, by a parallel simulated annealing engine, which produces the n-best versions of the text. These versions are then run through a set of adjustments to make them grammatical. The results are then run through a set of transformations to correct spelling, deal with abbreviations, make the revision formal or informal, or do some other simple syntactic transformations to produce the final texts. So when I'm working interactively with Inkwell, I do pretty short runs of the optimizer. For my typical run, the optimization function you just saw would be invoked 200,000 times. The algorithmic rhyme function, 3.2 million times. The algorithmic echo function, about 181 million times. The n-gram computation, 400,000 times. The personality computation, 1 million times. And the function, all different, 200,000 times. So without the caches and all the other stuff I've done, to do that, the short run would take 2 days. Doing all of the optimizations and the caches, a short run takes 2 minutes. So to make this run fast enough to be tolerable, I did a bunch of performance stuff. Some cases I rewrote common Lisp functions. So remove duplicates. I don't know how they came up with the algorithm they use. I rewrote it and made it 600 times faster than the implementation that I was using. Some things are obvious, like gathering all the alternative wordings in parallel, along with the static constraints and predicates on them. Obvious, but with some uncertainty, is running copies of the simulated annealing engine in parallel, dividing up the work. Simulated annealing has 2 main parameters, the number of temperature steps and the number of iterations within each temperature. My usual settings for these are 20 and 10,000. When divvied up among 16 cores, each processor does 20 temperature steps of 625 iterations. So the question is this as effective as running the single processor version? Well, I don't know. But the results are okay, and I can bump the parameters up when running offline. And so what's okay, what's not okay? Maybe it produces a slightly different version. N-grams were a problem. So there were so many of them, and I needed to look them up fast, so I used the clever string encoding that I mentioned earlier. Most importantly, I put caches in front of all the hard computations. This made the biggest difference. Most of these caches get extremely large. And the last thing was to embrace Martin Reinhardt's philosophy. So he's a guy at MIT. Most of the caches benefit from being filled up by the separate threads, which means to correctness freaks that I should synchronize to not duplicate work or look stupid. I don't do that. I just let each thread bang away as if we're the only thread in the world. And the result is that access patterns might be pretty nutty, but never wrong. And even if they were wrong, the only result would be slightly different wordings. That was a yawn. I have a couple of compilers built into Inkwell as well. So the templates are compiled. I have a couple of pattern matchers. I pre-compile the personality and language models for the writers. Luke, which was the dictionary of categories, has phrases in it, so those get compiled. The hash tables, some of them are hard to construct, and so I compile and dump them. And then the transformations at the end are compiled into Lisp code. This is in Potsdam, Germany. So let's look at how Inkwell uses senses and n-grams to produce sensible text. The first components are the semantic type and senses. So here's a simple template. WordNet stores senses of words in a simple sentence like, I like dogs. It's not clear what is meant by dog. Should we get burgers? No, I like dogs. Here are the senses associated with the word dog. So there's 7 of them. When Inkwell knows the semantic type for the word or phrase it needs, it can produce more sensible English. On the other hand, being sensible is not always part of contemporary poetry and fiction. So if I just said, give me some revisions, some versions of the sentence, I like dogs, and I don't constrain it in any other way, here's what it comes up with. I like detents, franks, clicks, cads, wieners, heels, bounds, frankfurters, weenies, wienerwurst, hot dogs, bounders, blackguards, fire dogs, frumps, andirons, dog irons, pauls, domestic dogs, and hot dogs. When I give it the semantic category, noun animal, it comes up with curs, animals, peaks, as in Pekingese, toys, beasts, creatures, puppies, wolves, foxes, barkers, Newfoundlands, bitches, canines, brutes, strays, corgis, lapdogs, and doggies. So what this says is that even when the semantic type is known, that might not nail down the right sense. In this case, a sense structure is created from a set of positive and negative words. For each positive word, Inkwell expands out from that word along synonym links and assigns a weight based on distance measured in number of hops. If two word clusters intersect, the weights of the words at the intersections are increased, and negative words are treated symmetrically. So for the sense that's based on the words dog and wolf, this is part of the sense. So basically, it's a set of words and weights associated with them. So you can think of it as a kind of a word cloud. And what Inkwell does is it runs that word cloud over WordNet and finds the words that are closest in distance to them. So here's how Inkwell treats the template we just saw. So it says, I like, and then find an animal, a noun animal, make it plural, and find things that have the sense of dog and wolf. So you can see that it's basically found fairly reasonable ones. A toy is a toy dog, so like a Pekingese or a pug. And a coy dog, which I didn't know, is a cross between a coyote and a dog. So Inkwell can start with specific word suggestions or with senses. Here are the synonyms Inkwell finds when the cognition-related verb think is specified. And here's what it finds using a sense specification in the same search parameters. So it's hard to read, so you can see it finds a lot of stuff. N-grams help Inkwell produce syntactically correct sentences like this. So basically I said, same thing, pick a word for dog using senses, then I don't know whether to use is or are, you figure it out. And so it figured out dogs are animals, toys are animals. And what it is it referred to the 3-gram database and the 2-gram database. And the dogs are animals, that wasn't a 3-gram I had. Dogs are had a high score. Dogs is had a lower score. Are animals had a high score. And is animals had a lower score. So that's how it decided through optimization how to make that grammatical. So sometimes the right thing to do is nothing at all. So I discovered the concept of a null word, which makes slightly off sentences just right, again using n-grams. So here it's choose a word for dog, make it plural, then I don't know if it's is or are, and I don't know whether it's a, an, or nothing. And it comes up with pups are animals, dogs are animals. And the computation, as I mentioned, for n-gram compliance is complicated. So this is a slightly munged version that makes it make more sense that dogs are animals is the right one. But notice that dogs as animals is not far behind, and that sounds not bad, dogs as animals. The notion of halo is a good example of how Inkwell is designed to mimic writerly thinking. A halo is a mood device. Specify a set of words, and Inkwell starts with each of those words, fans out along synonym arcs. Where several of these wave fronts hit, those words are given more weight in the revision process. Given the happiness halo, the woods are lovely, dark, and deep revises to, the words are bright, light, and high. And changing only the governing halo, it produces, the woods are hot, rough, and cold. And there's a bunch of built-in halos. My first foray into making an artificial writer was to have Inkwell write haiku. By that I mean contemporary English haiku. Japanese form doesn't translate perfectly to English, so many English language haiku poets don't even try. Inkwell does try to keep the syllable count to 17. I chose haiku because they are dense, they are an extreme form of poetry, and poetry is an extreme form of writing. In general, a haiku is made up of nouns or images that express seasons, times, durations, flowers, certain types of animals, etc. These form the base senses for the keywords in the haiku templates. Each such base sense is combined with externally supplied sense to produce the actual sense Inkwell works from. So here, going back, there's a flower sense base, and these are the words that make it up: flower, red, pink, white, and blue. So here's an example of one of these compressed templates. When I started to look at Inkwell as a full-fledged writer, I discovered that more abstract and generalized templates work better than the sort of more generic one shown earlier. So here, this is a component that says, put some preposition there, maybe. And a poem that comes out of this template is, as for the orange upon the scene, my dog ate it. So here are the prepositions. The algorithm to construct haiku is this: select a template, construct appropriate senses, set parameters randomly, produce a set of candidate haiku, and select the most sensible one. In general, Inkwell decides on the topic for a haiku by combining two sources of external sense words into a global sense. I call these triggers. The first source is input from a person. So here it's ice, river, bridge, snow, wind, cold, trees. The other is taken from a sample from one of the 75 texts Inkwell knows about. The writer sample is chosen randomly, but the result is always a small number of non-trivial words taken from contiguous text. That is, words related to the topic at that place in the sample. So here's an example of 7 words chosen from Capote's In Cold Blood: state, death, penalty, demanded, Friday, first date, and 9 words chosen from one of Shakespeare's plays: repeat, curse, small time, heart, grossly captive, honey, words. These two sources are combined, and the resulting global sense is combined with the senses associated with the keywords in the selected haiku. So like the flower sense that we saw before. This combination is biased toward the global sense. This is the effect of forcing Inkwell to choose related words for the key parts of the haiku. That's how Inkwell is able to produce a quirky but coherent observation such as, tuned adrenaline, my music, a beat boogied head full, when supplied with the words guitar, blues, loud, and music. So that is, one of my colleagues came over, Ron Goldman, I think Adrian might know. He said, put in guitar, blues, loud, and music, and this is what Inkwell said: tuned adrenaline, my music, a beat boogied head full. Except for the parameters that control local sense making, which is set high, all of the other Inkwell constraint parameters are set randomly. Here's a haiku written from the template I just showed. As for the sticker in the morgue, my death watch employed it. So one of the things I learned early on is that Inkwell performs best when it knows what you want it to say, assuming you're not looking for crazy ideas. I've been working on a program that will take text and make sense of it, meaning assign to each word the sense that best goes with the flow of the sentence, that is, its apparent meaning. I've been working on this for a while and have good but not great success. So here's the basic approach. First, you parse the sentence. Then you figure out which words need to have harmonious senses relative to each other and by how much. For each word, gather all possible senses, then optimize the assignment of the senses using simulated annealing and cosine similarity and a few other things. So Inkwell uses the Stanford parser, and the result is simple. I like dogs, I like dogs. The only substantive words are like and dog. They must make sense together to the tune of almost 100% because they're right next to each other. Now we make all the senses. So most of the exploration of this problem centered on how to make those senses. What works best is to basically use all of the synonym types in the WordNet entry for the word, combined with a thing called the derivationally related forms. The hypernym chain, which is the ontology, the semantic type, and as negative words, the antonyms. So this sense is combined with a sense made out of the gloss words, that is its dictionary definition, the proportion 75% to the weird synonym types, and 25% dictionary definition. So a derivationally related form is a word of a different part of speech that is derived from the same root. So here are the words in the sense for dog found this way, ordered from most important to least and alphabetically within groups. So you can see it starts off animal, canid, canine, canis, dog, domestic, domesticated animal, etc. And voila, figures out that like means care and dog means domestic dog. It figures this out because one of the other ingredients that I didn't mention was, in the absence of stronger evidence to the contrary, the most likely sense is used in WordNet. Stores the words in senses in decreasing order. This is one of the trickiest sentences that I worked on. Dogs bark. It's tricky because the right sense of bark is the fourth most frequent. So something from the sense associated with dog needs to pull it up in ranking. The required evidence comes from looking at the word for the noun bark, which is derivation related to the verb bark. The noun bark is defined as the sound a dog makes. So now, a tricky one. I like dogs with bread and ketchup. And here's the sort of relative strengths of the pairs. And it's figured out that dog means wiener, bread means staff of life, and ketchup means ketchup. So Google Translate uses machine learning. And so here are some translations of I like dogs with bread and ketchup in different languages, and in all cases it just picked dog as dog, not even the Australian version near the bottom. So now I'm going to skip to the experiment. So as I mentioned, I took this to a writer's workshop, and three things happened there. The first is you give a reading. So I read 18 haiku produced by Inkwell to them. Second thing is a writer's workshop where published poets sit and they critique the poems. Then the third thing is a lecture. Now the interesting thing is the title of my lecture, and I did that in that order, the title of my lecture was, "Is my program a better writer than you are?" Nevertheless, none of the poets guessed that the poetry I brought was written by my program. So here's what they said about the reading. Terse condensations took the top of my head off, evocative, funny and profound, natural, personal and rhythmic, compact fluid energy, whimsical elegance, wry and elliptical. For the writer's workshop, they said, wow, wonderful, combines ideas beautifully, very cool, everything works very effectively. Yes, very subtle, fantastic, wonderful humor, ominous and pretty, wonderful too, playful, taught something, changed something. There's whimsy in these, surprising language. Like a war going on between the two sides of the brain, but the same brain. Amazing variety, funny, serious, simple, complex, philosophical, plain-spoken, language, words, and phrases never heard before, powerful image, large and small at the same time. The next day, when I gave my lecture and the people in my workshop were there, almost like a cartoon, their jaws just fell open. They said, no, that can't be right. So I don't know if this is the Turing test or not, but these very accomplished poets thought that it was pretty good poetry. Thank you.